In this video, we're going to focus on linear regression using the least squares method. And this approach will help us to write a linear equation that best fits the data in the table shown below. So let me give you a visual illustration. So let's say we have these data points, which I'm going to highlight in blue. Now, these data points don't all fall on a straight line. However, what we can do is we can calculate the equation of a line that best fits this data, where all of the points are as close to as possible to that line. Now, what we're going to do is we're going to use a method called the least squares method to find the equation of the line. And then once we have it, we're going to test that equation to see how accurate it is in giving us the y values when we input the x values. And then we're going to confirm our answer using Excel. So let's begin. So the first thing we're going to do is we're going to create a table. This table is going to have 4 columns. So the first column is going to be x, the second column is going to be y, the third column will be the product of x and y, and then the last column will be x squared. Now let's plug in the values. So the first x value is 1, next is 2, and then 3, 4, after that is 5, 6, and 7. Now let's write the corresponding y values. So it's going to be 1.5, 3.8, based on what we see in this table, and then it's 6.7, 9.0, 11.2, 13.6, and then 16. Now for the next column, we need to multiply x and y together. So 1 times 1.5 is 1.5. 2 times 3.8, that's going to be 7.6. 3 times 6.7, that's 20.1. 4 times 9 is 36. 5 times 11.2, 56, and then 6 times 13.6, that's 81.6. Now 7 times 16, 7 times 10 is 70, 7 times 6 is 42, 70 plus 42 is 112. Now let's calculate x squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Now the next thing we need to do is we need to take the sum of each column of numbers. So let's go ahead and do that. So let's start with the sum of the x values. So let's add up every number in the first column. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That's going to be 28. Now let's take the sum of the y values. So 1.5 plus 3.8 plus 6.7 plus 9 plus 11.2 plus 13.6 plus 16. So that's 61.8. Now, let's find the sum of the next column, the sum of the xy values. So 1.5 plus 7.6 and so forth, all the way to 112. If we add those 7 numbers, we're going to get 314.8. Now let's find the sum of the x squared values. So 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. That's going to be 140. Now let's write down the important information that we've gleaned from this table. The sum of the x values is this number here. So that's 28. Now the sum of the y values is 61.8. These values are important because it's going to help us to calculate the slope and the y-intercept of the linear equation. Next, we have the sum of the xy values, and that's 314.8. And finally, we have the sum of the x squared values, which is 140. So now that we wrote that, let's get rid of this. So the linear equation will be in this format. Y is equal to mx plus b. In statistics, you might see an equation like this. Y is equal to b0 plus b1x. So what you need to know is that the slope, the number in front of x, is m or b1. They're the same. So I'm just going to write that here. So the slope of the line is equal to m, which is how you'll see it in algebra, but in statistics, you might see b1. Now the y-intercept in algebra is represented by the symbol b. So I'm going to highlight that in blue. In statistics, you'll see it as b0. So these two numbers, they're the same. In this video, I'm going to focus on the linear equation in slope-intercept form as taught in algebra. That is in this format, y is equal to mx plus b. But I want you to see the relationship between how a linear equation is described in algebra compared to how it's described in statistics. Now let's talk about how we can calculate the slope in this example. So the slope is equal to n times the sum of the xy values minus the sum of the x values times the sum of the y values. And then we're going to divide that by n times the sum of x squared minus the sum of x squared. By the way, n is the number of values that we have in our data. So we have 7 points, thus n is 7. So let's plug everything into the slope formula. So this is going to be 7 times the sum of xy, which is 314.8, minus the sum of x, so that's 28, times the sum of y, which is 61.8, and then divided by n. Now the sum of x squared, that's 140, and then minus the sum of x, which is 28, but we're going to square that. And so this is what we're going to get. So now let's plug everything in. 7 times 314.8 minus 28 times 61.8, that's 473.2. And then 7 times 140 minus 28 squared, that's 196. So dividing these two numbers, this is going to be 2.4142857. So I'm just going to rewrite that at the bottom so we can save that for later. So this is the slope of the line. I'm not going to round it early because we're going to need our m value to calculate our b value. So now we can get rid of this. Now let's calculate the y-intercept, b. So this is going to be the sum of the y values minus m times the sum of the x values divided by n. So the sum of the y values, that's 61.8. Our m value, we're going to use the most accurate number that we have to get an accurate b value. So this is 2.4142857. If we round it too early, it will affect our b value. So that's why I don't want to round it too early. The sum of the x values is 28 divided by n, which is 7. So if you plug this in, you should get approximately negative 5.8 on the numerator, divided by 7. This will give you a b value of negative 0.828571. All right, so now let's get rid of this, and we no longer need this information. So to write the linear equation, we need to plug in our m value and our b value into the slope-intercept equation. So it's going to be y is equal to, I'm going to round the slope to 2.41. And then I'm going to round b to negative 0.83. We don't need to use the exact answer. So this will be a good enough approximation of the data that we have in the table. And let's check it. So let's see what our y value will be if we plug in an x value of 2. So this is going to be 2.41 times 2 minus 0.83. And so we get 3.99. Now 3.99 is not too far away from 3.8. So that's a good approximation. Now let's try plugging in a different value. Let's go with 5. So 2.41 times 5 minus 0.83. So this is equal to 11.22. 11.22 is very close to 11.2, so that's an even better approximation. Now let's try one more. Let's try an x value of 7. In this case, I get 16.04. 16.04 is very close to 16. So thus we could see that this linear equation fits the observed data very well. So now you know how to use the least squares method when performing linear regression. That is when you need to write a linear equation that best fits the observed data of some type of experiment or something. Now what we're going to do at this point is that we're going to use Excel to quickly get the slope and the y-intercept, because once we have m and b, all we need to do is plug it into this equation and we have our linear equation that best fits the data. And sometimes when you're performing a science experiment, or if you have a lab report and you need to write a linear equation that best describes the data, Excel is a quick and simple way to do it. It'll save you a lot of time. So here we have Excel, and what we're going to do is we're going to plug in our x and our y values into columns B and C. So let's start with the x values. So it's 1 is 7, and then let's input the corresponding y values. So it's 1.5, 3.8, 6.7, 9, 11.2, 13.6, and 16. Now the next thing we need to calculate is the slope. So in cell C9, type in equal slope, open parentheses. Now notice that it says the known y values. You want to highlight the values in the y column. Once you do that, press comma, and then it says the known x values. Highlight the values in the x column, close parentheses, and then hit enter. And notice that we get the same slope, 2.414, 2857, which is what we got earlier in this video. So now we're going to calculate the y-intercept using Excel. So if you type in equal intercept, open parentheses, highlight the y values, press comma, and then highlight the x values, close parentheses, press enter. Now it gives you the b value, the y-intercept, which is negative 0.828571, which is what we had earlier as well. So as you can see, this is a very time-saving method to calculate the slope and the y-intercept of the linear equation that best fits the data. So that's it for this video. Hopefully you found this to be educational. If you like it, Don't forget to hit that subscribe button, and thanks for watching.